So it's two critical areas that I think come up pretty regularly that I like to place emphasis on. The first one being the proper training of system operators, right? So we have the design engineers, people that are experts in design and understand hydrogen combustion. Those aren't the people that are operating hydrogen systems once they get put into place. The system operators are. Those operators need to understand the systems and the hazards and the design engineers, it's their obligation to try to minimize the risk that a mistake made by those operators turns into something significant. We really have to try to push as an industry, and this happens already, but we need to always keep this in mind, is that we want to rely on engineering controls rather than operators making decisions or making actions, right? Wherever possible. Because the reality is every one of us makes a mistake eventually. And so we need to make sure that those systems are not, if a human makes a mistake in the operation of the system, maybe it's in an abnormal condition, or maybe it's in maintenance. This is a really, prominent area where mistakes are made is in maintenance. That operator making a mistake shouldn't, you know, lead to a catastrophic event. And so putting all those engineering practices in place to prevent that from happening and thinking that through in the design phase is critical. Another critical area is at the junction points for your major system components in hydrogen. I'm actually going to be talking in a presentation on this as it relates to BrainDrip and IQ4H2's energy storage product next month at the Center for Hydrogen Safety Conference in Las Vegas. And this is really about some of the risks associated with hydrogen systems and how upstream risks can carry downstream and become higher consequence. So a good example here would be oxygen getting into your hydrogen system, high upstream in your hydrogen system, and then that translating through like a compression system, for instance, and then building up large capacity storage with a combustible mixture, right? And so now in your storage system, your combustion consequence is quite high, even though that failure or that flaw originated upstream. And so you really have to be careful when putting hydrogen systems together that you assess those risks that may be coming from another portion of the system. Um, so so the best way on the general public topic, the best way to relay to the general public that safety measures are in place. This is really to lead by example and eliminate significant events from occurring in the first place through good engineering. Every company that's involved in hydrogen influences public perception. It's pretty easy to damage that perception, and it takes a long time to repair it. There's a lot of companies out there that understand this from other industries and place safety at really the utmost importance here, having a strong safety culture, and that is what we strive to achieve as well. So some example companies that really, have this figured out are the automotive companies like Toyota, as well as other companies like Caterpillar and NextEra Energy here in the United States. So really, you can tell the public something is safe all day long. You can't easily explain to the general public something like our continuous monitoring fiber optic sensor systems that are in our products. We can't really explain those well to the public and how they prevent significant events from occurring. You have to just use those tools and develop highly valuable tools and show the public over time that those systems are safe.